Welcome to qnawire.
Hello students, in this question we have to balance some chemical reaction. In our first reaction, we can see that carbon dioxide is reacting with H2O to give carbonic acid. So let's balance this reaction. If we compare number of carbon atoms in the reactants, it is 1, and in the product it is also 1. If we look at number of oxygen atom in the reactants, it is 3, and in products it is also 3. And the number of hydrogen atoms in reactants is 2, and in the product it is also 2. This reaction is already balanced. Now let's look at the second chemical reaction. In this reaction we can see that limonite, that is Fe H2, is reacting with 15 moles of O2 and 10 mole of H2O, and it is giving us FeOOH 4 moles. So here was also 4 moles of FeH2. We have to predict all the other products that will be formed. So this reaction formed two products. One is limonite, that is FeOOH, and second will be sulfuric acid, that will be H2SO4. Now balance this chemical reaction. We can see that number of hydrogen atoms in the reactants are 20, and in the product we have already formed 4 hydrogen atoms. So H2SO4 must contain 16 more hydrogen atoms. Therefore, number of moles of H2SO4 formed will be 8. Now you can see that number of sulfur atoms in products are 8, and in reactants these are also 8. Number of oxygen atoms have also been balanced. So this will be the balanced chemical equation, and 8 moles of sulfuric acid will be formed. Now let's look at our third reaction. In this reaction we have been told that the feldspar is converting into adularia. Now we know that the feldspar get hydrated to form adularia. So adularia is a hydrated form of feldspar. So this must be adding up to n moles of H2O to give this reaction in which feldspar will form adularia. This will be the balanced chemical equation. Now let's look at fourth reaction. In fourth reaction, we have been told that magnetite, that is Fe3O4, is converting into hematite, that is Fe3O4. Hematite is actually Fe2O3. Now we know that magnetite is oxidized to form hematite, so we can show this like this. So now let's balance the chemical equation. To balance number of Fe atoms both sides, we will multiply Fe2O3 by 3 and Fe3O4 by 2. Now we can see that number of oxygen atoms in the reactants become 8 plus 2, that will be 10, and oxygen atom in the products became 9. So to balance both sides, we will multiply O2 by half, so half moles of O2 will be reacting. If we have to only write the whole numbers, then we can multiply all these coefficients by 2. So this will become 4, this will become 1, and this will become 6. So all our balanced equation will be 4 Fe3O4 plus 1 mole of O2 will give 6 moles of Fe2O3. This will be the balanced equation. Now let's look at fifth equation. We have to form malachite by this reaction. So we know that its formula is Cu2CO3 dihydroxyl. Now this will be formed, and the second product that will be formed along with this is hydrogen. This will be the balanced chemical equation for formation of the malachite. Now in reaction F, we have to carry out the reaction of 3 moles of cuprous and 2 moles of carbonate ions along with 2 moles of water, and we have to form azurite. Now, formula of azurite is Cu3CO3 whole twice and dihydroxide. Now this will be formed, and the second product that will be formed will be hydrogen gas. So this will be the balanced equation. Now let's look at the last equation. In this, zinc 2 plus ions are reacting with bicarbonate ions, that is HCO3 negative, and we have to form, so it will form smithsonite. The formula for smithsonite is ZnCO3. Now it will also form hydrogen gas in half moles quantity. If we have to balance the chemical equation in such a way that we are remained with only whole numbers, so we will multiply all these by 2. So finally we will have 2 zinc plus ions react with 2 bicarbonate ions, giving zinc carbonate of 2 moles and 1 mole of hydrogen gas. This will be the balanced chemical equation for synthesis of smithsonite. I hope you found this solution helpful. Thanks for watching.